Hello and welcome to Chapter 6 of Math 127 at UNLV. This is Section 6.1. This will be the first section of Chapter 6. This has 2 videos to go along with it, and this is the first part of that video series. So Section 6.1, we're going to be talking about angle measure. Because this is the first section of Chapter 6, we're going to be dealing with a lot of definitions in this first section, this first video. So first off, let's look at positive angles and negative angles. So if we're talking about a positive angle, we have this point here, the vertex, where these two sides meet. If we call this one the initial side, this one would be the terminal side. And our angle from our initial to the terminal is going counterclockwise. So much like when we were talking about the unit circle, when we moved counterclockwise, it was a positive measurement. When we went the other way, it was a negative. So this would be the same in this case. If we have our vertex and our initial side are 1, if we're going in a negative direction until we hit the terminal side, this would be a negative angle. This one is positive. So again, this is more of a recall type item, like when we were talking about, again, the unit circle, depending which direction we were going, it gave us either a positive measurement or a negative measurement. Now you guys are probably used to talking about angles in degrees. But in calculus and other math type classes, you're going to be talking about radians. And hopefully you've been dealing with Chapter 5 enough that you're used to this discussion of radian measures and not degrees. So first, let's talk about a definition of a radian measure. And the definition is as follows. If a circle of radius 1 is drawn with the vertex of an angle at its center, so again, if a circle of radius 1 is drawn with a vertex of an angle at its center, then the measure of this angle in radians is the length of the arc that subtends. So here's a new term. It pretty much just means that closes in that angle. So subtends the angle. So if we have this unit circle, so a circle of radius 1, and we have some angle or some angle formed, instead of talking about the degrees like we used to in the past, we're talking about radians. And so what radians does is it's the length, this green portion here, hopefully you can tell the difference. It's the length of this green portion in radians, and that's what we're talking about of a radian measure. Radians we abbreviate as RAD. So this green would be the radian measure of the angle, and we're just going to call this theta. So if we have some angle drawn within this unit circle, the length of the arc around the outside is the radian measure of this angle. All right, I'm going to erase this. Again, if you need to pause and copy it down, feel free. So as I mentioned, most people are used to talking about angles in terms of degrees. So what's the relationship between degrees and radians? So that's what we're going to look at here. So the relationship between degrees and radians. So we have the following, 180 degrees, well that's what? That's half a circle, and from our unit circle that we've been talking about, half a circle is what? Well that is pi radians. If we start at 0 and go halfway around the circle, that's a measurement of pi. 1 radian, well it would just be 1/80th of that half of a circle. So it's 180 degrees over pi. So 180 over pi degrees is how the equivalent measure of 1 radian. And 1 degree is equal to pi over 180 radians. So these second two don't have to necessarily know as much, as long as you know from the first one that 180 degrees, half of the circle, is equal to pi radians. You can just do algebra. If we want to know 1 radians, well, we'd have to divide both sides by pi, and that gets us the second one. Or if we wanted to know 1 degree, we'd have to divide the left side by 180, which means we have to divide the right side by 180, and that'll give us both of those measurements. All right, so let's look at a couple examples of converting between radians and between degrees. So we want to express 60 degrees in radians. So if we have 60 degrees and we want to go from degrees to radians, well, what did we have to do? We had to multiply. So this is the third value that I gave to you guys, because this is degrees, so the degrees will cancel out, and this gives us just some value in pi, which is our radian measures. So if we multiply 60 times pi over 180, the 60, this is like 60 over 1, so the 60 cancels with the 180 and gives us 3, so we get what? Pi over 3, which again, if we look on our unit circle sheet, if we look at 60-degree measurement, that's pi over 3. So basically, if we want to go from degrees to radians, we multiply by pi over 180. So let me write this down as a shortcut for you guys. So if we want to go from degrees to radians, we want to multiply by pi over 180. If we want to go from radians to degrees, well, then we do the opposite. Then we multiply by 180 over pi. So that's sort of our shortcut. So if we want to go from degrees to radians, that's this first one. We multiply by pi over 180. Let's look at another example. So if we call this 1, if we want to express pi over 6 in degrees. So now we want to go from radians to degrees. So that's the second one. Radians to degrees means we multiply by 180 over pi. So we're going to do pi over 6 times 180 over pi. So now we can see that the pi's cancel out. 6 cancels with 180 gives us 30, which means that pi over 6 is equal to 30 degrees. And again, if you look at your unit circle sheet, you'll see that to be true. And just as a note, so when no units are given, then assume it is radians. So if you're given a value, a measurement of an angle, and it doesn't say degrees or something like that, just assume that they're talking about radians then. All right, let's move on. All right, so next we're going to talk about standard position of an angle. And again, another definition here for you. So we have the following. An angle is in standard position if it is drawn in the XY plane with the vertex at the origin and its initial side on the positive x-axis. So, a few examples here. The first one, if we have our initial side on the positive x-axis, the origin is, the vertex is at the origin, we have a positive angle, that one is said to be in standard position. Again, if the initial side is on the positive x-axis, vertex is at the origin, this one is in standard position. We could also have one that starts initial side on the positive x-axis, go a full time around the circle and then some. This one is also in standard position because it meets the qualifications. Initial side is on the positive x-axis, the vertex is at the origin, and then our terminal side just ends up depending on how far we travel around the vertex. All right, some few more examples. If you need to pause, copy that down. Again, that's fine. So we have the following definition. We say that two angles are coterminal so as a term there, coterminal. So two angles are coterminal if their sides coincide. So if you look at examples 1 and 3 here, if I would have drawn this a little bit better. So in angle 1, this maybe goes around, what, 45 degrees. In number 3, it goes around a full time and then another 45 degrees. So these two actually end up at the same, their sides end up in the same position. It's just that one went around the circle a full time before that last 45 degrees. So 1 and 3 would be considered coterminal because their sides would coincide. So let's look at an example. So we want to find angles that are coterminal with our theta is equal to 30 degrees in standard position. So using this idea here between 1 and 3, well, we can say what? We have 30 degrees. If we add 360, if we go around the circle one full time, that gives us what? That gives us 390 degrees. So here's two angles that are coterminal, 30, 390. What if we went the other way? So what if we do 30 minus 360? This gives us minus 330 degrees. So all three of these, 30 degrees, 390 degrees, minus 330 degrees, these are all coterminal angles because their sides all end up at the same position. All right, so that ends video 1 for section 6.1. Come on back and we'll deal with the second part of 6.1.